I present our paper Potential of 3D Visualization and VR as Boundary Object for Redesigning Green Infrastructure, a case study. We are an interdisciplinary team of researchers from different disciplines such as geoinformatics, meteorology, and human geography. My name is Janine Poessneck and I am the social scientist in the team. I will now present our approach. We know that the number and intensity of extreme events such as heat waves or heavy rainfalls will increase in future due to the climate change. In this context, green infrastructure plays an important role in making cities resilient towards extreme events and promoting a sustainable urban development. Green infrastructure is embedded in and interacts with a complex urban environment. Addressing this complexity requires an interdisciplinary perspective and the involvement of different actors. An interdisciplinary approach is, for example, represented by the concept of planetary health, which requires consideration of different thematic areas, such as the built environment and socio-economics, when dealing with environmental stresses. We have applied this to the topic of heat stress, but I won't go into too much detail about this particular concept here. So, our approach is to use 3D visualization as a boundary object to analyze complex, heterogeneous data from different disciplines, and to present it on a PC or in an immersive virtual reality environment to bridge communication boundaries in the context of urban planning and green infrastructure redesign. We understand 3D visualization as the spatial representation of data using 3D models, but also abstract data using streamlines, for instance. A boundary object means, in our case, a specific tool that can be recognized and used by different actors. Depending on disciplinary backgrounds, local requirements, and individual needs, the presented information will be interpreted and adapted differently. So these are our research questions. First, to what extent can 3D visualization and VR be used as a boundary object to create a thematic digital twin on the basis of which decisions can be supported? Second, what is the potential of 3D visualization and VR as a communication tool for green infrastructure redesign? Third, how can data of different characteristics be integrated and represented in 3D space? And fourth, how can usability be realized across different user groups? Now I present our conceptual framework in the form of a diagram. 3D visualizations and VR can act as a thematic digital twin. We interpret a digital twin as a virtual representation of a system, like planetary health, considering different thematic areas. It includes the impact chain for a specific challenge such as heat stress in order to enable well-informed decision-making in light of future changes through the climate crisis. Against the backdrop of multiple environmental stressors, 3D visualizations and VR can thus be used as a boundary object to integrate very different data sets and to overcome communication challenges between diverse stakeholders. For instance, planning authorities, residents, housing companies, civil society initiatives, and the scientific community, all with different interests, needs, and levels of knowledge. And of course, there are different spatial scales that need to be considered. And this brings me to our case study. We conducted a case study in the large panel housing estate Leipzig-Grünau at the western fringe of the city of Leipzig. We selected this area because we can build on experiences and extensive data from previous studies at the Helmholtz Center for Environmental Research in Leipzig. The development of the entire housing estate, highlighted in the map with the yellow border, has been investigated since 1979 within the framework of a sociological long-term study. The most recent resident survey took place in 2020. Another project is called heat stress. In this context, a state-of-the-art urban climate model was applied for the district Grünau North. And respective micrometeorological simulations were conducted using the Poem4U model. This was done by my colleague Daniel Hertel. The third project is U-Vital, where we focused on a specific neighborhood in the district Grünau North. You can see the yellow star in the map, and which is also the case study area of what I present here. The initial research in this area, where mainly elderly people live alone, was on housing upgrading, but it has been extended to redesigning green infrastructure based on the creation of different scenarios. For the implementation of the visualization application, my colleague Carolin Helbig used the Unity game engine, which is a development environment for computer games and other interactive 3D graphic applications. In the application, heterogeneous data from very different sources are included, such as socio-economic data from the municipal statistics, questionnaire data from the resident survey, qualitative data from interviews, urban climate simulations with Poem4U, and data from the urban climate analysis by the city of Leipzig, but also photos and orthographic photos, sketches, sound effects, and 3D models such as buildings or vegetation. For visualization, we have real-world objects such as buildings, vegetation, infrastructure, outdoor furniture, and so on. Their position in the status quo scenario is based on orthographic photos, site inspections, and information from Google Earth. Different kinds of 3D models can be selected in the Unity Asset Store. In addition, abstract objects were added, as you can see on the slide. Streamlines of the wind field simulation and values of the PET, the physiological equivalent temperature, by column, both from the Poem4U model, but also information from the action plan of the already mentioned urban climate analysis. 2D data, such as socio-economic statistics, questionnaire data, and photos are used as elements of the user interface. In the application, a navigation bar gives the possibility to show and hide different datasets. So the complexity can be reduced by adapting the view according to different user groups and the question to be addressed. There are different drop-down menus, for example, one for selecting different scenarios. Another one is for showing the simulation results. There it is also possible to select individual time steps. There's also a drop-down menu where the user can select a perspective, either avatar, avatar with a figure, or drone. The avatar perspective offers the greatest immersion in a VR environment. Additionally, 2D data can be opened by clicking on a purple or blue 3D eye in the scene. The sound, in our case traffic noise, is controlled by selecting a scenario and can be muted completely. In our study, we incorporated 3 scenarios in the application: status quo that shows the current state of the area, and scenarios 1 and 2 as possible future scenarios in which various elements have been added to the status quo. For instance, water features, facade shading, additional vegetation, playground, and seating possibilities. One basis for the development of the scenarios were the results of the residents' survey. For example, the residents were asked about desired measures to reduce heat stress in the building and in the living environment. The installation of solar shading devices was the most preferred measure in the case study area. The scenarios were also based on data from the qualitative interviews and on other best practice projects in the area, as illustrated by the photo on the slide. As you can see on this slide, we organized several transfer events to present the 3D visualization to different stakeholders. As VR environment, we used the Tessin WizLab at the UFZ Leipzig. We discussed the 3D visualization and VR and how to use them with participants from city offices of Leipzig, environmental initiatives, housing companies, planning offices, but also with other researchers using similar approaches and technologies. The stakeholders agreed that 3D visualization and VR are useful for communication with the local residents. The tools could help to exchange knowledge and improve mutual understanding. Furthermore, we presented and discussed the 3D visualization during a meeting of the Tenants Association in the case study area with the residents and representatives of the housing company. This led to a lively and interesting discussion. In our last stakeholder workshop within the framework of the heat stress project, we asked whether the participants could use the 3D visualization and VR in their field of work. Almost half of them answered yes. We can finally say that 3D visualization and VR helps to bridge communication boundaries. We provide evidence that it can be used to analyze and integrate complex and heterogeneous data. And it can serve as a boundary object for the development of a thematic digital twin. Thus, we see great potential of using 3D visualization and VR in urban planning and green infrastructure redesign. Nevertheless, it has to be stated that the development of the presented application requires appropriate resources like finances, staff, and time, and specific hardware infrastructure. We can further conclude that the visualization of different kinds of data according to their characteristics allows for systemic data integration. Finally, the transfer events provided unique opportunities to verify the usability of the presented visualization. Depending on the actors and the focus question, the level of detail in the scene could be customized by showing or hiding different data layers. For future research, it would be beneficial to enlarge the databases, for example with mobile measurements of environmental stressors. It would also be interesting to conduct additional climate simulations with input data based on the scenarios. We have already started to test this. In order to facilitate the integration of visualization tools into the daily work of different actors, the development of workflows for their implementation would be helpful. And the last point, concerning the usability of the presented tools, formal user evaluation tests should be conducted. Due to the COVID-19 pandemic and delays in the project process, they were not possible in our case. So you can see there are a number of points where our approach can be expanded or further developed. Thank you very much for your attention.